we have covered expressions. When we have an expression equal to another expression, then we have an equation. Starting this lecture, we're going to talk about how we solve equations. And we're going to start with the simplest equation. Linear equation means that inside the equation, we have different terms in an expression. If every term has power to the variable at most 1, then you have a linear equation. Linear equation means that every term, if it has a variable, the variable's power is at most 1. So let's look at a few examples. Say 2x plus 7 equals x plus 1. This is a linear equation because there are 4 terms. This term has variable x with power 1. This is a constant, so it does not have any variable. This is another term with variable power to 1. And this one is a constant. So this is a linear equation. On the other hand, a x squared plus 7 equals x plus 1 is not a linear equation because you have a term x squared which has a variable with exponent 2. And if you have 2 variables, let's say x equals y plus 1, then this is also a linear equation because even though there are 2 variables, each variable has power 1. This is also linear. On the other hand, xy plus 1 equals y plus 1 is not linear, even though that you have each of the variable has power 1, but we have a product here. So when you have a product, you have to kind of combine the exponent together. So this has a power 2. So this is not a linear equation. And in this lecture and the next, we're only going to focus on linear equations with only one variable, and we see how we solve it. So for example, we're going to solve an equation like the following. Example 1, 2x plus 6 equals 12. How we solve this linear equation. So first we need to understand, what do we mean we solve this? We solve this by to get a value of x. This is our goal. X equals what? Such that this equation hold. Now, there is a very kind of basic approach is, let's try different values of x, right? Let's say x equals 0, then 2 times 0 plus 6 is a 6, so this is not equal to 12. So x equals 0 is not a solution. And how about x equals 0, the left-hand side equals a 6, the right-hand side equals 12, which is not equal. So x equals 0 is not a solution. How about x equals 5? The left-hand side is 16, the right-hand side still 12. So this is not a solution. So you see how it goes, right? We try different values, and maybe you can convince yourself that there will be a value such that the left-hand side equals right-hand side. But it's a guesswork. It's kind of not easy. In fact, this requires some trial and error, takes time, and requires, I would say, smartness. And here we're going to talk about a solution, a method of solving this mechanically, kind of dummy-like, if you will. So let's first set our goal. The goal is get the variable alone on one side of the equation. After all, in the end, we want to get x equals something. This is the value, a constant we want to put on the right-hand side, and x equal that thing, and that's our solution, right? So that's our goal. What's our tool? The tool is when you have an equation, if you apply the same operation, identical operation on both sides of the equation, the equation still hold. This is our tool. And when we say identical operation, we're only going to focus on the simple operations: plus something, minus something, multiply something, and divide something. We're only going to focus on this simple operation, even though that this idea of applying identical operation on both sides, the equation still holds. It actually includes all possible operations you can think about. We're only going to focus on the simple things. So let's see how we use this tool. 2x plus 6 equals 12. Let's minus 6 to both sides. So that means 2x plus 6 minus 6 equal 12 minus 6, right? I'm minus 6 both sides of the equation. This gives us 2x equals 6. Now we divide by 2 both sides. We get 2x divided by 2 equals 6 divided by 2. And this gives us x equals 3. So this is what we are trying to find out, x equals 3. And this is the value such that this equation holds. And that's the solution to this equation. And when you get the solution, it's better to take the value and plug in to make sure that the equation holds. So you see, we have solved the first example of a linear equation. Let's look at another example. What about there are more than one terms of x there? So let's look at how to solve x for 5x plus 5 equals 3x plus 1. Now, when you have more than one terms with a variable x, the goal is again, move all the terms with x there to one side of the equation. Move all terms with variable to one side of the equation. And the tool again is our applying identical operation to both sides of the equation. So let's think how we move the 3x to the other side. Well, we get rid of the 3x on the right side by minus 3x both sides of the equation. Okay, I'm going to ignore the minus 3x. It means that to both sides. And we got 5x plus 5 minus 3x equals 3x plus 1 minus 3x, right? Still, equation holds. Now, minus 3x, we're getting rid of the 3x on the right side of the equation. We get 2x plus 5 equals 5x and minus 3x together, the like terms, and we get 2x. And then we're minus 5 to both sides. We get 2x plus 5 minus 5 equals 1 minus 5. So we get here is 2x equals minus 4. And at this point, we're going to divide by 2 both sides. So we have 2x divided by 2 equals minus 2 divided by 2, which gives us x equals -2. So in this example, we look at an equation with several terms with variable x. And the idea is we're going to combine them, moving all the terms with x to one side, and then move all the terms without x to the other side. And then we combine the terms with same signature or the like terms, and we solve x. Let's look at another example when the expressions have fractions. So it's more complicated looking, but we'll see that it's exactly the same way of doing this. So let's look at a 2 over 3x plus 2 equals 1 over 3x minus 1. When you have fraction as coefficients, the way I prefer is just multiplying a integer so that to make every term in integer, because 2 over 3 and 1 over 3, we can multiply 3 to both sides. And then when you get 3 over 2, 2 over 3x plus 2 times 3 equals 1 over 3x minus 1 times 3. And in here, you're going to using distributive law, and which get rid of the fractions. So you have 2x plus 6 equals x minus 3, right? 1 over 3x times 3 is x. Minus 1 times 3 is minus 3. Similarly, 2 over 3x. At this point, this looks like the same as example 2. And we're going to move the x to the left side by minus x both sides. Minus x both sides. So you have 2x plus 6 minus x equals x minus 3 minus x. This has the effect of removing the x on the right-hand side, and you have x plus 6 equals -3, right? We have combined the like terms, the terms with x. X plus 6 equals -3, so you have x equals -9 by minus 6 to both sides of the equation.